For nearly half a century, Voyager 1 has been traveling farther from Earth than any other human-made object. Long after its primary mission ended, the spacecraft continued its lonely journey into the darkness between the stars. Then, something unexpected happened. Communication became unstable. Data turned into unreadable fragments. For months, engineers wondered whether humanity's most distant explorer had finally reached the end of its incredible mission. At a distance of more than 15 billion miles from Earth, every command takes almost a full day to arrive. There is no quick repair, no emergency maintenance, only patience, precision, and hope. When Voyager stopped responding correctly, many believed the spacecraft's aging systems had simply reached their limit. But the story didn't end there. After months of careful troubleshooting, NASA engineers managed to restore communication by shifting the spacecraft's software into a different section of memory. It was an extraordinary achievement considering Voyager was built using technology from the 1970s. Against incredible odds, the spacecraft came back to life and resumed sending scientific information from a region of space no other probe has ever explored. What those instruments continue to reveal is changing our understanding of interstellar space. For decades, many people imagined the space beyond our solar system as an almost empty vacuum. Instead, Voyager has shown that the region outside the heliosphere is surprisingly active. Invisible plasma surrounds the spacecraft. Magnetic fields stretch across enormous distances. Energetic particles travel through the galaxy carrying information about distant cosmic events. One of Voyager's most valuable instruments measures plasma waves. Although space is nearly empty, it still contains extremely thin gas made of charged particles. These particles can vibrate, producing low-frequency plasma oscillations that scientists can detect. Every measurement helps researchers estimate the density of the interstellar medium surrounding the spacecraft. As Voyager travels farther away, those measurements continue to change. Scientists have discovered that the density of interstellar plasma is not constant. Instead, Voyager moves through regions where particle concentrations rise and fall, almost like crossing invisible weather systems. These variations may have been shaped by ancient stellar explosions or by the large-scale motion of gas throughout our galaxy. Another instrument aboard Voyager measures magnetic fields. These measurements revealed that the Sun's magnetic influence does not simply fade away smoothly. Instead, beyond the Heliopause, Voyager entered an environment dominated by the magnetic field of the Milky Way itself. The direction and strength of these fields shift over enormous distances, influencing the movement of cosmic rays and charged particles throughout interstellar space. Cosmic rays themselves tell another fascinating story. These incredibly energetic particles originate from powerful astronomical events such as exploding stars and other high-energy processes throughout the galaxy. Voyager has detected changes in cosmic ray intensity that help scientists understand how the heliosphere shields our solar system from this constant bombardment of radiation. The heliosphere acts like a giant protective bubble created by the solar wind. When Voyager crossed its outer boundary in 2012, it became the first spacecraft to directly sample the interstellar medium. That historic crossing provided evidence that our solar system exists inside a much larger galactic environment, one that is far more dynamic than scientists once believed. Today, every new transmission from Voyager adds another piece to this enormous puzzle. Instead of revealing an empty wilderness, Voyager is uncovering a complex region filled with plasma, magnetic structures, energetic particles, and changing conditions that continue to surprise astronomers. Its journey is far from over. Even traveling at more than 38,000 miles per hour, Voyager will need tens of thousands of years before passing close to another star. Yet every day, it continues drifting through unexplored territory, sending humanity a steady stream of discoveries from the edge of known space. As Voyager 1 continues its journey deeper into interstellar space, scientists are beginning to build the first direct picture of our galactic neighborhood. Unlike telescopes that observe distant objects from Earth, Voyager is physically traveling through the environment itself, making measurements no observatory can obtain. One of the most intriguing discoveries involves the structure of interstellar space. Rather than being completely uniform, Voyager's data suggests that the space between stars contains regions with different particle densities, temperatures, and magnetic characteristics. These invisible boundaries may extend across enormous distances, creating a complex landscape that researchers are only beginning to understand. Scientists also believe our solar system currently resides inside a region known as the local bubble. This enormous cavity was likely formed millions of years ago by multiple supernova explosions. Those ancient stellar events pushed surrounding gas outward, leaving behind a vast region of relatively low-density material. Voyager's observations help researchers study how our solar system interacts with this remarkable environment. Another important area of research involves magnetic fields. Throughout the galaxy, magnetic fields influence how gas moves, how cosmic rays travel, and even how new stars eventually form. Voyager's magnetometer continues recording subtle changes in these fields, giving astronomers valuable information about the invisible forces shaping our corner of the Milky Way. Meanwhile, plasma wave observations continue to provide another piece of the puzzle. By measuring natural plasma oscillations, scientists can estimate the density of material surrounding the spacecraft. Over time, these observations reveal gradual changes that help researchers identify different regions of interstellar space and understand how matter is distributed beyond the solar system. Every new data point improves computer models used to simulate our galactic environment. These models are important for future deep space exploration. Understanding radiation levels, magnetic fields, and particle densities could one day help engineers design spacecraft capable of traveling safely far beyond the planets. Voyager is also teaching us something remarkable about scientific exploration itself. Despite operating far beyond its original mission, the spacecraft continues producing valuable discoveries decades after launch. Few missions in history have provided useful scientific data for so long, making Voyager one of NASA's greatest engineering achievements. Its famous golden record still travels aboard the spacecraft, carrying sounds, music, greetings, and images from Earth. Although it was created as a message for any distant civilization that might someday discover it, the record has also become a symbol of humanity's curiosity and desire to explore. Every signal Voyager sends reminds us that exploration does not always require dramatic discoveries. Sometimes the greatest breakthroughs come from patient observation, careful measurement, and decades of continuous learning. The farther Voyager travels, the more it helps scientists understand the environment surrounding our solar system and our place within the Milky Way. Its mission continues to inspire new generations of astronomers, engineers, and dreamers. Someday, future spacecraft may follow the path Voyager pioneered, traveling even farther into the galaxy using technologies we have yet to invent. Until then, Voyager 1 remains humanity's most distant explorer, silently crossing interstellar space while continuing to expand our knowledge of the universe one transmission at a time. If you've enjoyed this journey beyond the solar system, don't forget to like the video, subscribe for more space discoveries, and share your thoughts below. What do you think Voyager 1 will reveal as it continues traveling into the unknown?